Factor theorem. The factor theorem is a direct result of the remainder theorem. In those examples that we had just done, when your remainder is 0, that's the factor theorem. Okay, so for a polynomial p of x, if you substitute if you substitute p of a and you get 0, then we say x minus a is a factor. The way we looked at it before is like down here. For a polynomial p of x, if x minus a is a factor, then p of a is 0. You get no remainder. So sometimes if I divide a number, I get a remainder. If I divide two things, I get a remainder. Sometimes I don't. You're actually doing the same process of substituting. It's just that if you get no remainder, it's called the factor theorem. And if you get a remainder, it's called the remainder theorem. But you're doing exactly the same thing. You're just substituting from the factor. Okay? That's all it is. Same theorem. All right? So, but they will say this is a factor of that polynomial. When they say this is a factor of the polynomial, you've got to know that the remainder is 0. See, if it's not a factor, they'll say when you divide by this, you'll get this remainder. If they just say this is a factor, you know that the remainder is 0. Okay? So, looking here, just at this result, now we've been working with this a little bit, so it should be a bit easier to look at. You know, this is our division transformation. Polynomial in x is a to the x times, it's your, whatever you're dividing by, times the quotient plus the remainder, where ax is your factor, x minus a. So polynomial in x is x minus a times your quotient plus your remainder. Now, if I divide the remainder when p of x is divided by x minus a, we know is pa. You know how we know that our remainder is by substituting the a into the polynomial? Your remainder is p of a. You know how we do p of 1 and you get an answer? So I can write the remainder as a number, or I can write it as pa. All right? So polynomial in x is x minus a times your quotient plus that's your remainder, which is pa. But if your remainder is 0, I can put this as 0. Polynomial in x is x minus a times your quotient plus 0 remainder. In other words, your polynomial in x is just x minus a times qx if the remainder is 0. In other words, x minus a is a factor. All right, now, just down here, if x minus a is a factor of the polynomial, we write polynomial in x is x minus a times the quotient. There'll be no plus 0. There'll be no remainder. All right? Okay, now, the factor theorem. If your polynomial, in a polynomial p of x, if p of a is 0, then x minus a is a factor of the polynomial. So, what we're going to do, we're going to divide this. So, if polynomial in x is 2x cubed minus x squared minus x plus 8, show that p of 2 equals 0, and hence what we're going to do here is we're going to factorize that, then find the other factors by long division. All right? Now, here is a polynomial. I'm asking you to factorize it, right? You'll have no idea how to factorize it. So I've got p of x is, so what we're doing here is we're using this factor theorem to help us divide a polynomial. So we've given us the polynomial. They're saying show that p of 2 equals 0 and hence find the other factors by long division. So let's do p of 2. What do you get? I'll let you just write that out. P of 2 here. So p of x is that. So p of 2 is 2 times 2 cubed minus 2 squared minus 8 times 2 plus 4. We're supposed to get 0. We get 16 minus 4 minus 16 plus 4. That looks like 0. So if p of 2 is 0, so since p of 2 equals 0, therefore x minus 2 is a factor. Do you get that? We normally work the other way. What we've been doing so far is they've been saying when you divide by x minus 2, the remainder is that. And don't we do p of 2 and get some value? But we're saying because p of 2 is 0, when you divide by x minus 2, you're getting no remainder, right? So that means x minus 2 is a factor. A factor fits exactly. If I say to you, what are the factors of 36? You'll tell me 9, 4, 18, 2, because it goes into it exactly with no remainder. That's what a factor is, no remainder. So if you know that x minus 2 is a factor and you have to hence find the other factors by long division, we're now going to divide this x minus 2 into the polynomial by long division. So we go like this. So this is what we do. The question might be factorize that. Sometimes they'll give you a hint that x minus 2 is a factor. Sometimes they won't. And you've got to work out what your first factor is. And we're working on that tomorrow. So now that we know that x minus 2 is a factor, when I divide, I should be getting a remainder of 0, but my quotient will be at the top. So I'm dividing this. So what have I got? 2x squared. So I've got 2x cubed minus 4x squared. Subtracting, I get 0, positive 3x squared. Bring down the 8x. And x into 3x squared is plus 3x. 3x times x is 3x squared. Take away 6x. I get, remember it's negative 8, take away negative 6, which is negative 8 plus 6 is negative 2x plus 4. And here I've got minus 2. So minus 2 times x is minus 2x. Minus 2 times minus 2, or negative 2, is plus 4. Great. I've got no remainder. Fantastic. Therefore, do you remember how we set out our thing? Therefore, 2x cubed minus x squared minus 8x plus 4 equals, how do we normally set it out? That times that. Equals x minus 2 times 2x squared plus 3x minus 2. I don't need to put plus 0. Now you just factorize the second one. And now we've factorized the polynomial. So we use division of polynomials to help factorize polynomials. So you know how to factorize quadratics, x squareds type equations, but you can't factorize x cubes. So this is helping us factorize x cubed expressions. So we've got x minus 2, what do you think? 2x, x, I think it's plus 2 minus 1. 2x squared plus 4x minus x minus 2, and it's factorized. Now you should know how to draw that. Do you remember? Okay. Yes. So we've learned then how to draw that.